Today we are going to discuss Newton forward interpolation. Okay. So the first problem he has given is the find the population in the year 1895. The given a table he has given. So year versus the population in the concerned years. In 1891 it is 46 lakhs. In 1901 it is 66 lakhs. 1911 it is 81 lakhs. 1921 it is 93 lakhs, and 1931 it is 101 lakhs. So we have to find out the population in the year 1895. So here 1891 you know, 1901 you know, but you didn't know the population in 1895. So using Newton forward interpolation we have to find out the population in 1895. Okay, first we have to construct a difference table for the given data. So I have taken the x column as the year and the y column as the population. So in 1891 it is the 46 lakhs. So similarly you have to write the in 1901 it is the 66 lakhs, and in 1911 it is 81 lakhs. 1921 it is 93 lakhs. 1931 it is 101 lakhs. Okay, next what you have to do is that you have to construct the differences. So 66 minus 46 it is 20. That you have to write between these two values. So here I have written 20. Similarly you have to find out 81 minus 66. The difference you have to write it here. Similarly 93 minus 81. The difference you have to write it here. Similarly 101 minus 93. The difference you have to write it here. Okay, let us look at. So 81 minus 66, the difference is 15. Similarly 93 minus 81, the difference is 12. Similarly 101 minus 93, the difference is 8. So next we have to find out the again 15 minus 20. 15 minus 20 it is nothing but minus 5. It is a negative value. You have to write the minus 5. Similarly you have to find out the 12 minus 15. 12 minus 15 is minus 3. 8 minus 12 is minus 4. Okay. Next you have to find out the next differences. Minus 3 minus of minus 5. Minus 3 plus 5. It is plus 2. Okay. Similarly minus 4 plus 3. It is minus 1. I have written here. So next minus 1 minus 2. It is minus 3. That is the fourth differences like this. This is the way to construct a difference table. Next what we have to find out is we have to find out the population in 1895. Okay. So first we have to name this data x naught, y naught, so and so. So for the first one is 1891. I have considered as the x naught. So next one is x1. Next one is x2. Next one is x3. And next one is x4. This is the notation you have to remember. Similarly 46 you have to name it as y naught. X naught corresponding value is y naught. Similarly if you do that one, y1, y2, y3, y4, you are going to get the values like this. Okay. Next one delta y naught. This is column is first difference, therefore delta y naught. Next one delta y1, y2, y3. Okay. So next one delta square y naught, delta square y1, delta square y2. Similarly delta cube y naught, delta cube y1. Next one delta power 4 y naught. So this is the naming the values. So what is the Gauss forward interpolation formula is f of x naught plus ph is equal to y naught. So next one is p delta y naught, p into p minus 1 by 2 factorial into delta square y naught, p into p minus 1 into p minus 2 by 3 factorial into delta cube y naught, plus so on and so forth. You have to remember the notation of p. How we have written the p? First is p power 0. Second one is p power 1 you are written. Next one p into p minus 1. Subtraction you remember. P into p minus 1. In the next one p into p minus 1 into p minus 2. In the next value p into p minus 1 into p minus 2 into p minus 3. So this is the notation you have to adapt. Okay, So how to remember y naught, delta square y naught, delta cube y naught values, that also I will discuss. Okay, where p value is x minus x naught by h. So x is equal to 1895. The given, we have to find out the population in 1895. Therefore x value is 1895. X naught is 1891. X naught value is 1891. H is equal to 10 because 1891 and 1901, the difference is 10. Similarly 1901 and 1911, it is 10. Therefore H is equal to 10. P is equal to x minus x naught by h. Just to substitute the values, you are going to get P as 0.4. Okay, therefore f of 1895, substituting in the formula, you are going to get y naught means 46 plus, similarly p delta y naught, p is how much? 0.4. here it is p 0.4. delta y naught means here this value is 20, therefore 20. Similarly p into p minus 1, 0.4 into 0.4 minus 1 by 2 factorial into minus 5, delta square y naught is this one. Similarly 0.4 into 0.4 minus 1 into 0.4 minus 2 by 3 factorial into 2 means delta q y naught. Similarly if you do that one, minus 3 delta power 4 y naught. Okay, so if you observe these values, so 46, 20, minus 5, 2 and minus 3, these are the continuous values you have substituted. Just you check it, y naught, so otherwise you can check it here, 46, 20, minus 5 plus 2 and minus 3, 46, 20, minus 5 plus 2 and minus 3, these are the continuously you have to substitute in the Gauss forward interpolation formula. So therefore f of 1895 you come across with the 54.45. so just check it whether the answer is correct or not. So 1895 lies between these two numbers, therefore the answer should lies between 46 and 66, and the value is 54.45. Therefore the answer is correct. So just you observe this one, in Newton forward interpolation only these values we have to substitute in the formula. These values, just you have to draw a line like this, these values are only you are going to substitute in the formula. Y naught, delta square y naught, delta cube y naught, delta power 4 y naught. Okay, thank you. Today we are going to discuss Newton backward interpolation. Okay, so find y of 25. Given y of 20 is 24, y of 24 is 32, for 28 is 35, for 32 it is 40, using Newton backward interpolation. Okay, so first what you have to do, you have to construct a difference table having the columns, first column as x and the second column as y and so on. For 20 it is 24, I am writing here. Similarly for 24 it is 32, for 28 it is 35, similarly for 32 it is 40. So next what you have to do is you have to construct differences for this one. So in Newton forward you have to write it here the symbol as delta. In Newton backward you have to write it as the nabla. So if you reverse you will get the nabla. Okay, so 32 minus 24 you are going to get as 8. Similarly 35 minus 32 3, 40 minus 35 it is plus 5. Always the difference you have to write in between these two. 32 and 24 difference is 8, that you have to write in between these two numbers. 35 and 32, this difference you have to write in between these two numbers. 40 and 35 difference you have to write in between these two numbers. Okay, similarly 3 minus 8, the difference is minus 5, you have to write it here. Similarly 5 minus 3, it is plus 2. Okay, similarly 2 plus 5, the difference is 7, you write it here. So this is the way to construct a difference table. Next what you have to do is you have to name the values. x0, this is x1, this is x2, this is x3. Similarly these values y0, y1, y2, y3. So from starting it is x0, x1, x2, x3. Corresponding values are y0, y1, y2, y3. In Newton backward, from here onwards you have to give the naming. Okay, in Newton forward, from here you are going to give the naming. In Newton backward, from here down to up you have to give the naming. Okay, so this is nabla, therefore nabla y3 you have to get. It has ended with y3, therefore you have to go for the nabla y3. This value is nabla y2, this value is nabla y1. Okay, similarly here it is nabla square y3. From bottom to up you have to give the naming, therefore this is nabla square y2. Similarly this is nabla cube y3. It is nabla cube, therefore this is nabla cube. This is nabla square, all the values are nabla square. This is nabla only. Okay, next let us look at the Newton backward interpolation formula. So f of xn plus ph, here the formula is not x0 plus ph, this is xn plus ph. Okay, yn plus p nabla yn plus p into p plus 1 by 2 factorial into nabla square yn, p into p plus 1 into p plus 2 by 3 factorial into nabla cube yn, plus so on and so forth. Okay, how to remember the p notation? For backward you have to remember the p notation as addition. So first starting value is p into p plus 1, next p into p plus 1 into p plus 2, so on and so forth. Okay, so next how you have to remember the yn, nabla square yn, nabla cube yn. So if you how to remember these values means, so this arrow 40, so next 5, 2, 7, this means this bottom diagonal line, this represents these values. Next one, p value is x minus xn by h. Formula x is equal to 25. For 25 you have to find out the Gauss Newton backward interpolation, therefore x is equal to 25, xn is equal to 30, xn is equal to 32, so h is equal to 4, h is equal to the difference between any two values is 4, therefore h is equal to 4. Just to substitute in this one, you are going to get it as minus 1.75. P value is minus 1.75. So therefore f of 25 is equal to yn. Yn means this 40 you have to write it here. So only these values you are going to substitute in the Newton backward interpolation formula. So 40 plus p minus 1.75 and 5. Okay, next minus 1.75 into minus 1.75 plus 1 by 2 factorial into 2. Only in this rectangular the values only you are substituting in the formula. Similarly 7 you are substituting here, nabla cube y3, 7 you are substituting here. Just if you do the simplification, f of 25 you are going to get it as 32.945. Let us check whether this value is correct or not. 25 lies between 24 and 28, therefore the value should lies between 32 and 35. 32.945 means the value is correct. In Newton backward interpolation, always you have to remember these diagonal values only you are going to substitute in the Newton backward interpolation. If you consider the Newton forward interpolation, these upper values you are substituting 24, 8, minus 5, 7. So if it is Newton backward, 45 to 7 you are going to substitute in the formula. Okay, thank you. Today we are going to discuss Gauss forward interpolation. Find f of 2.5. Given f of 1 is equal to 1, he has given. F of 2 is equal to 8, he has given. F of 3 is equal to 2.7, sorry 27. F of 4 is equal to 64, he has given. Okay, so what you have to do is the next you have to form a difference table for the given data. What you have to form? The difference table for the given data. So for that one I have taken x as one column, y as another column. So here the data given is 1, x value is 1, the corresponding y value is 1. Therefore 1, 1 I have written. So next similarly if you go for the f of 2 is equal to 8, x value is 2 and y value is 8. So next one, if you go for the next 3 and 27, x value is 3 and y value is 27. So next one is 4 and 64. Next what you have to do is you have to find out the differences. So here is the 1, here it is the 8. 8 minus 1 is nothing but plus 7. That plus 7 you have to write it in between these two numbers. In between these two numbers, that is 7, you have to write it here. Similarly 27 minus 8, how much? That value you have to write it here. Okay, it is 19 plus 19. 27 minus 8, not 8 minus 27. 27 minus 8, 19. So the next 64 minus 27, it is plus 37. 37 I have written here. Similarly you have to find out the next differences. Here 19, here it is 7. 19 minus 7, it is plus 12. You have to write it here. Similarly 37 minus 19 plus 18, you have to write it here. Okay, so similarly you have to find out the next difference. 18 minus 12, it is 6. You have to write the difference here. So this is the way to construct a difference table. Okay, next what you have to do, let us look at. Next you have to know what is a Gauss forward interpolation formula. Okay, what is the Gauss forward interpolation formula? Let us discuss. So f of x naught plus ph is equal to the formula, what it says, y naught. The first term is y naught. So the second term is p into delta y 1 by 2. Okay, p into delta y 1 by 2. Okay, and the next term is p into p minus 1 by 2 factorial into delta square y naught. Okay, so and the next term is p into p minus 1 into p plus 1 by 3 factorial into delta q 1 by 2. Okay, similarly where p is x minus x naught by h. Okay, so now we have to know the notation, how we have written the p value. So here it is p. First here it is p for 0. Here you have written p. Next you have to write p into p minus 1. In Gauss forward you have to go for the negative onwards. That is, first you have to write the next subtraction, p minus 1 you come across with. Next in the next step what you have to write, this entire p into p minus 1 you have to write it here, and you have to add one more term, that it should be addition. That means previously you have written negative p minus 1, therefore you have to write p plus 1 by 3 factorial and so on so forth. Okay, so how to write y naught delta y 1 by 2 delta square y 1 naught we will discuss later, where p value is x minus x naught by h. So what is x? X value is 2.5. Okay, x value is 2.5. Okay, so next x naught is 2. Why I have taken x naught is 2 means we have to find out 2.5 what is the corresponding y value. So 2.5 is in between 2 and 3. So I think that it is closer to 2, and I have taken this 2 as the x naught. Okay, so next one, h value is 1. What is meant by h value? Here in the x column 1 and 2 the difference is 1, 2 and 3 difference is 1, and 3 and 4 the difference is 1, therefore h value is 1. So now we have to calculate the p value. P is 2.5 minus 2 by 1, x minus x naught by h. If you do that one, how much you are going to get? The value of p is 0.5. Okay. So next, similarly, we have to find out the f of 2.5. For 2.5, what is the corresponding y value? So for that one, before that one, you have to find out what is y naught value, delta y 1 by 2, delta square y naught, and delta q y 1 by 2 values. You have to get it. So how you will get? Let us discuss. Already we have considered this 2 as x naught. So the corresponding value 8 is y naught. Okay, the corresponding value is y naught. Okay, next one is you have to draw a horizontal line from connecting to x naught, y naught, and so on and so forth. You have to draw a horizontal line. Okay, so next you have to construct a lower triangle for this one. Lower triangle means this one. Similarly, from 12 to 6, you have to construct a lower triangle. So these are the values that we have to substitute in the Gauss forward interpolation formula. What are that values is y naught. Y naught is 8. So this next delta y 1 by 2 is nothing but 19. So next one, this 12 is nothing but delta square y naught. Next one, this 6 is nothing but delta q y 1 by 2. So what is in Gauss forward interpolation formula? Always the lower triangle values. Lower triangle values means these values only you have to substitute in the formula. Okay, then you will get the answer. Okay, so here we have delta y 1 by 2 is 19. Similarly, delta square y naught is 12 and delta q y 1 by 2 is 6. Okay, so if is y naught is 8. Next, if you substitute in this one, in place of y naught I have substituted here. In place of p I have substituted 0.5 and delta y 1 by 2 is 19. Similarly, if you substitute in this formula, you are going to get like this. Similarly, if you substitute in place of p 0.5 and in place of delta q y 1 by 2 is 6 and do the problem, f of 2.5 you are going to get it as 15.625. 15.625. So let us check whether this value is correct or not. So 2.5 lies between 2 and 3. Therefore the answer should lies between 8 and 27. So 15.625 anyway lies between 8 and 27. Therefore the answer is correct. Okay, next basically you have to remember in Gauss forward interpolation formula, what is that one is? So connecting x naught, y naught, you have to draw a line, horizontal line. Next you have to construct a lower triangle. The lower triangle, the corresponding values of the lower triangle are the values that you have to substitute in the Gauss forward interpolation formula. Okay, thank you. Today we are going to discuss Gauss backward interpolation. Okay, so what he has given is that we have to find out the y of 8. So the given problem is y of 0 is equal to 7 and y of 5 is equal to 11, y of 10 is equal to 14 and y of 15 is equal to 18, y of 20 he has given as 24 and y of 25 is nothing but equal to 32. So first we have to prepare a difference table for the given data. So for that one, first column you consider it as the x, second column you consider it as the y. So what he has given for 0, it is the value of y is 7. So for 0 I have to write the value of y is 7. Okay, similarly for y, for 5 it is the value of y is 11. So the the value of x is 5 and the value of y is 11. Okay, so next for 10 it is 14. So I have written 10 as 14. Okay, similarly for 15 it is 18. Similarly for 20 it is 24. For 25 it is 32. Okay, next what you have to do is that in the next step you have to find out the differences. First differences you are going to find out. So 11 minus 7, so 11 minus 7, it is nothing but the plus 4. So you have to write this plus 4 in between these two values, therefore between these two values you have to write the 4. Okay, so next 14 minus 11, it is 3, therefore you have to write the difference 3 in between these two values 11 and 14. Okay, next 18 minus 14, it is plus 4, you have to write it here. Similarly 24 minus 18, it is plus 6, you have to write it here. Similarly 32 minus 24, it is plus 8, you have to write it here. So always you have to write these differences in between the concerned values. Okay, in the next step 3 minus 4, it is minus 1, so I have written in between these two values it is minus 1. This is the second differences, delta square you are writing. Similarly 4 minus 3, it is plus 1, I am writing here. 6 minus 4, it is plus 2, I am writing here. Next one 8 minus 6, it is plus 2, I am writing here. Next third differences, 1 minus of minus 1 plus 1, 1 plus 1, it is 2. Okay, next one 2 minus 1, it is plus 1, I am writing here. Similarly 2 minus 2, it is 0. Okay, so next fourth difference, 1 minus 2, it is nothing but minus 1, I am writing here. Similarly 0 minus 1, I am writing minus 1 here. Okay, so next minus 1, again minus of minus 1, it is plus 1, minus 1 plus 1, it is 0. So fifth difference is 0. So this is the first you have to construct a difference table like this. Okay, next what we have to do is our Gauss backward interpolation formula is nothing but like this. F of x naught plus ph is nothing but equal to y naught. Okay, the formula is first term is y naught, second term is p into delta y minus 1 by 2. Okay, next one is p into p plus 1 by 2 factorial into delta square y naught. Third term how you are going to get like this, p into p plus 1 into p minus 1 by 3 factorial into delta q y minus 1 by 2. Similarly p into p plus 1 into p minus 1 into p plus 2 by 4 factorial into delta power 4 y naught. So let us look at the notation, how he framed the notation. First y naught. Okay, so don't think about this y naught. First p notation, how he has framed the p notation. First this is p, next one p into p plus 1 you are going to get. So first it is p, next p into p plus 1 means addition. Okay, next what you have to do, then next you have to go for the subtraction. Now you write the p into p plus 1 as usual. Next subtraction, p minus 1 you come across with. So now it is subtraction, next you have to do the addition. Therefore you write the same as usual, p into p plus 1 into p minus 1 as usual here up to here. Next you have to go for the addition. Already p plus 1 is there, you have to write p plus 2. Okay, in this way you have to remember the Gauss backward interpolation formula. So here the value of p you can find out using the formula x minus x naught by h. Okay, what is x naught, let us discuss. X is equal to 8, find y of 8 means therefore x value is nothing but 8. Okay, next one x naught, you have to consider it as 10 because why it is 10 means the value 8 lies between here 5 and 10. The value lies between here 5 and 10 x value, but it is more closer to 10, therefore I am deciding it as x naught, this x naught 10 as x naught. Okay, so h is equal to 5 because the differences between the x values is 0 to 5 it is 5, 5 to 10 is 5, 10 to 15 is 5, therefore h value is equal to 5. So therefore from this one if you consider this one, the p value you are going to get is minus 0.4. Okay, so next now we have to find out what is y naught, delta y minus 1 by 2, delta square y naught, delta q y minus 1 by 2, delta power 4 y naught, what are the different values. So for that one, now we have already considered this as x naught, the corresponding value, this 14 as the y0. So next value is nothing but how you have to frame these values means from first you have to form a triangle for this one. So from this y0, so you frame a triangle like this one. Okay, from this one also you have to frame a triangle like this one. So from this one also you will get like this. So next one, for Gauss backward interpolation always you have to consider these values. So if you consider this one upper triangle values comes for the backward interpolation. So 14 is the y0. Okay, next one delta y minus 1 by 2 is this one 3. This is delta square y0. This is delta cube y minus 1 by 2. This is delta power 4 y0. Okay, like this, these are the values. So if you do that one, y0 is 14. Y0 is 14. Okay, next one is delta y minus 1 by 2 is this one. Okay, next one delta square y0. This is delta square y0. Okay, next one, this is delta cube y minus 1 by 2 is equal to delta cube, this value is y minus 1 by 2. Similarly delta power 4 y0 is minus 1. Similarly, so if you do that one, f of 8 is in place of y0 I am writing 14. So p value is minus 0.4, therefore p value I am writing as minus 0.4. Delta y minus 1 by 2, already I have written delta y minus 1 by 2 is 3, therefore 3. Next one, in place of p I am substituting minus 0.4 plus 1 by 2 factorial into delta square y0 is 1. So similarly if you substitute the formula, so on and so forth, and simplify, you are going to get it as 13.9056 f of 8. So let us discuss whether this value is correct or not. So this value, whatever the value for 8, it should lies between 11 and 14. So this is anyway 13.9056, therefore the value is correct. In this way you have to find out the Gauss backward interpolation. So here you have to remember the only one thing is so you have to first consider the triangle, this upper triangle only you have to consider, that is the formula for the Gauss backward interpolation. Okay, thank you. Today we are going to discuss Lagrange's interpolation. Okay, so when we can use the Lagrange's interpolation, that is the first point we have to discuss. When we can use the Lagrange's interpolation, previously we have discussed Newton forward interpolation and Newton backward interpolation and central forward interpolation, central backward interpolation. Those 4 problems are having the equal intervals. So if you consider the Lagrange's interpolation, this problem, you come across with the unequal intervals. So if you consider the x variables, here it is 5, 6, 9, 11. The difference between these two is 1. Here it is, the difference is 3, and here the difference is 2. So the differences, the unequal intervals are having. So here it is, the difference is 1, 3, 2, unequal intervals. Then you come across with the Lagrange's interpolation. Okay, how to solve this type of problem? Okay, so we have to find out the value of 10. We know the value of y, and the value of 6, value of 9 is 14, value of 11 is 16, but we don't know the value of 10. So how to find out the 10? The value of 10 lies between 14 and 16, but we don't know the perfect value of the 10. To find out the perfect value of 10, we have to proceed in this way. 10 you have to write above the first variable of x, that is 5. Above you have to write 10. So here the formula how to remember means 10 minus 6, 10 minus 9, 10 minus 11, you have to write 10 minus 6, 10 minus 9, 10 minus 11 divided by 5 minus 6, 5 minus 9, 5 minus 11, 5 minus 6, 5 minus 9, 5 minus 11 multiplied by the corresponding value of 5 is 12. Therefore 12 you have to write here. So the next now you move this 10 to the second place, that is 6 above, you have to write it. So how you have to write the numerator values is again 10 minus 5, 10 minus 9, 10 minus 11, 10 minus 5, 10 minus 9, 10 minus 11. Don't write 10 minus 6. Okay. So the denominator values from here you have to do 6 minus 5, 6 minus 5, 6 minus 9, 6 minus 11, and the corresponding value is 13. Corresponding value is 13. Okay, the corresponding value is 13. Similarly, now you move on the 10 to the third place, that is above 9, and do this one. Okay, and next you move this 10 to the last value, that is 11 above, you have to write and do this one. So if you simplify this one, you are going to get the value as 14.67. So just you confirm it whether the value is approximately or correct or not. So the value of 10 lies between 9 and 11. That means the answer should lies between 14 and 16. Therefore 14.67 means the value lies here. Therefore the almost all the answer is correct. Okay. Thank you.